What up, geometry students? Let's do the big quiz review on areas and surface areas and volumes of prisms and cylinders, all sorts of good stuff. I'm giving you the answers. We're giving you the answers. Doesn't mean anything. You still have to find the answers. Key to prisms. I'm not censoring anything. You will be online for forever yelling at me. Okay. Yes. Area of the base times the height. Okay. Height might be height might not be a height that's readily apparent. It might be a different height. Um, just make sure you notice what the height would be here. Sometimes prisms can be on their side. This base is the triangle. Area of the base is 1/2 base times the height. That is the area of the triangle. That's the area of the base. So this is going to be 4. And then the height is 5. That's the volume. The volume, boom, 20. Surface area is hard to figure out. You can either split out the net or just kind of understand your triangles you have. You have 2 of these triangles, the shapes that you have, that are 2x4. So again, we have this 1/2 base times height, which is, this is 4. So I have 2 4s, which is 8. And I have one rectangle that's a 4x5. That's the rectangle that's on the bottom. So that's going to be a 20. So I have an 8 plus a 20 plus I have this rectangle on the outside, which is a 2x5. So that's a 10. And then I need this rectangle up on the top. How do I find that rectangle? I use the Pythagorean theorem. 16 plus 4 is 20. This is root 20. Root 20 is root 4, root 5, which is 2 root 5. So my last rectangle is a 2 root 5 by 5, which is going to be a 10 root 5. That's how I get 38 plus 10 root 5. Same deal, same type of object as up above. Only difference is I'm giving you a 30, 60, 90 triangle here. So if this is 3, this has to be 3 root 3, and this has to be 6. So that means this is 3, this is 3 root 3, and this is 6. Whoops. This is 6, this is 3 root 3. Now, it might be hard to see, but when you put these together, you can see that this length is going to connect with this length here. So that's 4. You'll be able to see that this must be 4. This must be 3 root 3. If this is 3, this is 3, this will be 4. So you can see we have those 3 rectangles that are like using the height of 4. So volume is the area of the base, which is 3 root 3 times 3 divided by 2, which is that 9 root 3 divided by 2. This is the area of the base. And then my height is this 4. So this will be 2 times 9 root 3, which is how we get the 18 root 3. And then the surface area, we have this area, which is a 12. This is going to be a 9 root 3 over 2. This is a 24. This is a 9 root 3 over 2. So I have 18 root 3 over 2, which is 9 root 3. And this is going to be a 12 root 3. So we can add them all together. I got a 12, a 24. I got a 9 root 3 over 2 twice. So a 12, a 24, a 9 root 3 after adding the 2 of them together, and then a 12 root 3. 9 root 3 and the 12 root 3, 21 root 3. Ooh. I think we're skipping one of these rectangles. I think we messed up. equilateral triangular prism. So that means this is 4 and this is 4. Means the surface area is going to be kind of easy because the rectangles are the same. What might be different is finding the height of the triangle. You're going to have to use our understanding of the 30, 60, 90 that exists here. So the area of the base, this is for the volume, is going to be 1/2 base times height. So that'll be 4√3 times the height, which is 5, gives us that 20√3. I have 3 of these 4x5 rectangles. I have 3 of these 4x5 rectangles. So I have 3 of these 20s, which is 60. And then I have 2 rectangles, 2 triangles. That's 2 area of the bases. So that's going to be 8√3s. All right, 8 sides. Here we go. We're going to have to focus on our triangle. This is 2. Split this in half. This is 1. What are these angles? Well, remember, we could look at our central angles. We could do 360 divided by 8, but then that'll be the top central angle, divide that by 2. Or you could do 180 divided by 8 to get that this angle is 18. This is 18. This is 90 minus 18, which is 72. If you think about a triangle where this is 1, you can understand that the tangent of 72 over 1 would be something that could be square, something that could be used. If you wanted to use your sine and cosine, you'd use sine of 18 and cosine of 18. You would have to take 1 over the sine of 18 and multiply it by the cosine of 18, which would be 1 over the tangent. I know it's kind of easy to see you have like options and to pick the best option. This is the tangent of 18. If this is 1, I would use this triangle and square this to realize this is the tan of 72. Or if you wanted to, you could say 1 over the sine of 18 times the cosine of 18. You'll get the same value. Anyways, that's this length. Maybe it's best to just say that this length is 3.077. Let's do the area of the base. The area would be the area of one of these triangles, which is 1/2 of the base times the height. That is the area of a triangle. Times 8 triangles. Cool. Times the height of 5. And I get this 123.107. Something happened. This is 2. Half of the base times the height is that. That's the area of one of the, I need to multiply that 8. That's the area of the base times the height. Yeah, so I had a large job. Then for the surface area, I need 2 areas of the base. So tan 72 is the area of the base. Need 2 of those. Then I need 8 of these 2 by 5 rectangles. So I have 80 plus 6.155. Maybe we thought that was 7. $86.155. Great. If this is 2, then half of the base times the height is that. Okay. Now, new thing, just like with triangles, when we have a base, the height sometimes lies away from the base. So the height is this vertical length. We don't care about this diagonal length. This doesn't matter. It's this that matters. It's going to be the same if I have a parallelogram, which you'll see in a second. We have a pentagon. Wait, did I make a mistake on the earlier one from angle? Oh my gosh, 180 divided by 8. Is 22.5. Holy cow. I'm so sorry.
Right. Oh,
I was thinking divided by 10. All right, so change this up. This is the tangent of 22.5. So the this is the tangent of 72. This is the tangent of 67.5. If that's 1. Whoops. Okay, that's the area of the base. That's the area of a rectangle times 8 is the area of 8 rectangles, triangles times 5. There's the volume. That's correct. $2.414. My bad.
it's frustrating, but it's still fun.
All right, let's see if I get the right answer. Two of these 67.25s times 8 is two of the bases, and then plus 80. 118.627. There you go. Sorry, I forgot. Make sure you do the calculations. All right, let's do the next one correctly. I can take 180 divided that by 5, and I get 36. So taking this triangle in here, I have this triangle here, where this is 36. 90 minus 36 gives me, this is so ugly. I'm just doing such a bad job. Ninety minus 36 is 54. You got a right triangle whose ratios can be so many different things. It could be tan 54 over 1. It could be tan 36 over 1. It could be sine 36 over 1 here. It could be cos 36 over 1 here. There's all your options. So I want the tan 54 over 1, or the ones there. This is the sine 36 over 1. This is the cosine 36 over 1. So this is going to be the tan of 54. You could also do 1 over the sine of 36 times the cosine of 36. Regardless of what you do, let's just write down the number. 1.376. Okay. Area of the base. Is 5 of the half the base times the height. There's 5 of my triangles. The triangle's areas are really the tan of 54 times 5. So the area of the base is 6.88 dot 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 times the height. Here's the problem. This is the height. How do I find this height? Well, I'm told that this diagonal length is 4. Oh, okay. I have a 30, 60, 90 triangle here that we need to take advantage of, which means this is 4, this is 2, this is 2 root 3. So the height is 2 root 3. So I'm going to take this 6.88 and multiply it by 2 square root 3. And I get this 23.8396, which is this value. For my parallelograms, I'm going to need this 2 root 3 again. I have parallelograms with this base length of 2. The height is also this 2 root 3. So we'll start with my area of my base, 2 of these area of the bases. So my surface area is 2 of the area of the bases, which I found. And then I have 5 of these 2 by 2 root 3s. And that's how I get the 48.405. Same deal. Now the area of the base is pi r squared. So I get 36 pi. Surface area, we have 2 circles. that are going to be 2 9 pi's. And we have one rectangle. Now, what happens when we unravel this? Well, we get that this length becomes this length of the rectangle, and that's going to be the circumference, 2 times pi times r. This by 4 means this is 24 pi. So I get 18 pi plus this 24 pi, which is how I get this 42 pi. Same deal here. Only deal again is that we need the height. Well, we're told this diagonal length is 5. This is a 45, 45, 90. This is 5 over root 2. Cool. Area of the base is again 9 pi, but the height is 5 over root 2. Multiply those together, and you get 45 pi over root 2. Now let's look at the surface area. Surface area is 2 of the circles. And then when I roll this out, I actually get this very long parallelogram. Maybe like orient it this way, where it's kind of rolled out like this. Well, we notice that this height is still the 5 over root 2. So that height stays the same. Guess what? The circumference of this will still be this length. It'll just be like the rectangle that you think. This will be 30 pi over root 2. So I have 18 pi plus this 30 pi over root 2. Get that. And we finish off with these two, which we practice in class. Key is to see the right triangles that are kind of coming out of the paper, these three-dimensional right triangles. So square, which means this is 4. This means this is 2. This is 2. Which means this length here, I have to use the Pythagorean theorem. 2 squared plus b squared equals 6 squared. I have b squared equals 36 minus 4, which is 32. b equals the square root of 32, which is root 16, root 2, or 4 root 2. Okay, for the volume, I want the area of the base times the height, but then I'm just going to take a third of it. 3 dimensions, triangles, divide by 3. The area of the base is 16. The height is 4 root 2. Divide that by 3. 64 root 2 over 3. Answer. Surface area, we have the square, which is 16. And then we have 4 of the triangles. The triangles have a base length of 4, and you can see this height of 6, this diagonal length. That is going to be the height of the triangle. So this is going to be 12 each. So I have 4 12s. So I have 16 plus 12, 24, 36, 48. And that's how I get 64. And finally, easy start. Area of the base times the height times a third. Area of the base is 9 pi. The height is 4 times a third. So I get 12 pi. But now the surface area is the tricky part. Okay, I have a circle. Cool. This is 9 pi. But when I unroll this, it becomes this portion of a new circle, which I'm going to kind of keep going around to understand. And what are the characteristics of this kind of net? Well, as we unroll this top part of the cone, we can see that the circumference of this circle becomes this arc length, which is 6 pi. That arc length here is 6 pi. We also notice that this diagonal length, which comes from the radius and the height, and a Pythagorean theorem, 3 squared plus 4 squared equals 5 squared, that, when unrolled, becomes this radius of this new circle. Now, for the surface area, I'm going to start with my 9 pi here. But now I need this area of this portion of the circle. Well, we have the entire circle, this big circle, is a 25 pi. That's the area. The entire circle's perimeter is 10 pi. Well, let's think about this. I want this area, so I'm going to take the entire circle's area, but I want only this much of this much, the portion. I have this 6 pi over 10 pi. Well, 6 pi over 10 pi simplifies to be just 6 over 10. What we find is that we can divide by 5 easily. This becomes 5, this becomes 2. We can also divide by 2 easily. This 6 goes away, this 2 goes away, we get 3, or we'll get 15 pi total out of this. 5 times pi times 3, or 15 pi. 9 pi plus 15 pi gives us that 24 pi. You notice it's pi times r times L. 5 times 3. That slant times this radius actually becomes the area of my little net. But like getting that and understanding it are two different things. So I hope we understand how to do this. You have to do them yourselves. If I would do anything, I would like do these problems over and over again until you always get those slant heights, those surface areas, and those volumes. So practice, practice, practice. It's no magical thing. You just have to practice, okay? Peace.